Astroseismology is essentially the science of the oscillations or pulsations in stars. So what we essentially do is we look at a star, and a lot of stars pulsate, like our sun also is oscillating a little bit, and I use oscillating and pulsating through another because I mean the same with that. And we look at that, and by our reasoning we can then infer the internal structure. It's a little bit at home, if you don't see it, but I shake you a carton with pasta or a carton with rice, you can hear it, or you hear there's different music and different music instruments, and this is what we now do with stars. So we listen to the stars, and then we can infer the internal structure. If we do that for a lot of stars along the stellar evolution, we increase our knowledge about the internal structure of each of these stars with evolution, and in that sense we can learn more about the evolution and put the things in order and know more about the details and how different layers interact in a star and what happens at crucial phases. So my focus in astroseismology is really on red giant stars. So these are the big evolved stars in which you have either hydrogen shell burning or helium core burning. And essentially astroseismology for these stars is only just over a decade old. So this is, as anything we know about these stars is from the last decade. And we've learned a lot. We've seen oscillations that not only probe the outer layers, but also that are sensitive to the core layers. So we can actually now distinguish for the first time between the helium core burning and the hydrogen shell burning stars. We've seen differential rotation in these stars. And so I think in that sense we've learned a lot about these stars which we did not expect a decade ago. I think there's a lot going to happen because we actually now only analyze the low-hanging fruit, so there's a lot to do in detailed analysis. We've learned about the stars, but we have not implemented anything into stellar evolution models, so I think that's a big step that needs to be taken over the next decade or maybe decades. And also we can use astroseismology in other fields. It has started a little bit by using astroseismology to determine the radii of planet host stars, and so inferring the size of the planets. We can also use this to study the Milky Way and have additional information on the stars in the Milky Way, and so map the Milky Way much better. There are probably many other fields where we can use this observation. So I think there's a lot to come. Also with the new mission, TESS mission, the Plato mission, we will get more data, more fields observed. So the future is great for astroseismology of red giant stars. It's a great honor and pleasure. It's very unexpected, and I feel very flattered by it as a person, but I think it's also for the field very good that there's a lot of attention, and then I get the opportunity to tell other people about this great field. So I think it's dual in that sense.